Hey and welcome. Today we will solve binary search interview question which mostly asked by companies like that, so let's get into it. First example here, we have numbers array starting from -1 and ends up at 12. Note that numbers are sorted and increasing as we go through the array, and our target number in this case is 9, so our algorithm should return index 4 obviously because it's where 9 located. Second example, again we have the same sorted array and this time we are looking for number 2 which does not exist, and we might return -1 for non-existing numbers. Let's see how we might solve this. So binary search is one of the searching methods that we can use with arrays to bump up the speed a bit more, but the whole concept of binary search is meant to optimize the time complexity for our search from here for usual linear search which has O of n time complexity to here, log n time complexity. But the workflow of how it works is super interesting because we definitely will have an iteration through given array, and typically an iteration over n length array would translate to O of n time complexity. Well, not all the times. Let's see how. In case of binary search, let's say that we have this array and we need to find number 6. In every single iteration we do, we will reduce the scope of our search by half and only focus on where we want to search until we hit number 6. So what I mean by that is, since the given array is sorted increasingly, what we can do is find the mid element and divide the array in two sections, left and right half. And here is the logic for this. We need to compare these two numbers, and if the number we are looking is larger than the mid number, then we know we might ignore what we have in the left side, including the midpoint as well, and look into the right half, since searching in the left half might be redundant now because simply the answer is not there, relying on the fact that the array is sorted. We will repeat this cycle once more with our reduced scope. This time the middle element will be 8, and of course other way around in this case. If the number that we are looking is less than the mid number, definitely right side is where we need to dig in. What will happen next is that we will repeat this cycle as much until the midpoint finally becomes a number that we are looking for. In this case, we only need to do it one more time. So we only left with 2 elements, and if we find the midpoint, we will have 6.5, which we will do a master floor on it, which will give us number 6. By the way, this 6 and 7 that we used in here are indices of these 6 and 7 from array. I specifically choose the number range between 0 and 10 to match their indices within the array. Now, if we do one last comparison, numbers are equal, and that is where we need to return our answer as a result of our search. With that being said, now let's jump into the code to implement this. So first, we need to define the left and right boundary indices in order to define our scope, which is initially the entire array. Now, as long as our left index is less than right index, we need to do some stuff. First one is to find the midpoint. So basic calculation of average borrowed from mass, left plus right divided by 2, which we will do a floor on it for cases of arrays or portions of arrays with even elements. Then we should check for if element in the mid index we found is the element that we are looking for, or target value. If so, we just return it because that is our answer. Now we need to take care of the case where we search for left half of the array. Remember that it was the case when target value we were looking for was less than the mid element. If so, we need to ignore the right half of the array and only narrow our focus into left half by updating right pointer to the one below the midpoint. Otherwise, we will check for left half by updating left pointer to the one above the midpoint. And please note that since this will run inside of our while loop, we will keep doing this as far as the left pointer is less than or equal to the right pointer. And at the end, we need to return -1 for cases where we cannot find any match. Now, if I run this, test cases are passing, and if I submit, we are in a good shape here. Let's jump into the time and space complexity. For time complexity, we will have O of log n, where n is going to be the number of elements in the array. For space complexity, it will be O of 1 constant because we just had a bunch of variables. So that was it for this video. Thanks for watching, and please leave a like, comment, and subscribe to the channel. I will put the link for arrays and a few other playlists in the descriptions for you to check it out. And finally, hope you enjoyed this video and stay tuned for the next one.